The birth of Earth. What if I told you that Earth almost never existed? That before there was a blue planet, there was chaos, firestorms, shattered worlds, and collisions so violent they could melt entire planets? And yet, from this cosmic battlefield, our world was forged. Could it be that we are living on the ashes of a planetary apocalypse? Let's travel back 4.6 billion years to witness the birth of Earth. Chapter 1. A Star is Born. Every story has a beginning, and ours starts in darkness. Picture the Milky Way galaxy over 4.6 billion years ago. In one of its spiral arms drifts a cold, vast cloud of gas and cosmic dust, so huge it could swallow thousands of solar systems whole. For millions of years, this cloud simply floats through space, quiet and undisturbed, until something changes. Perhaps a nearby star exploded as a supernova, sending a shock wave racing through the cloud. Or perhaps a rogue star passed too close, disturbing its balance. Whatever the trigger, gravity takes over, and the great collapse begins. As the cloud shrinks, it spins faster, just like a figure skater pulling in their arms. The center grows hotter and denser until deep inside a miracle occurs. Nuclear fusion ignites. At that moment, a star is born, our sun. The birth of the sun was not a gentle event. Winds of charged particles blasted outward, clearing away much of the leftover gas. But enough material remained, swirling around the newborn star like a giant disk. This was the protoplanetary disk, the nursery where planets would soon form. Inside this disk, tiny grains of dust began to collide. Most of these collisions were destructive, but some were gentle enough for the grains to stick together. Over millions of years, these grains grew into pebbles, then into boulders, and finally into enormous rocky bodies called planetesimals, the building blocks of planets. Imagine countless worlds the size of mountains, crashing into each other at terrifying speeds, merging into larger and larger embryos. This process was violent, chaotic, and incredibly slow. But it was how the raw material of our solar system took shape. In the inner part of the disk, where it was hotter, rocky planets began to form: Mercury, Venus, Earth, and Mars. Farther out, where it was colder, giant planets of gas and ice started to take shape: Jupiter, Saturn, Uranus, and Neptune. Our Earth was now a growing embryo, just one of many rocky worlds, but its story was far from over. In fact, the most dangerous and dramatic chapters were still to come. Chapter 2. The Hellish Early Earth. Our young Earth was not a peaceful world. Forget blue skies and green continents. This was a planet of fire. Imagine looking down from space. You wouldn't see land or oceans. Instead, you'd see a glowing molten sphere, a world still in the process of becoming solid. Its surface was a vast magma ocean, constantly bubbling and churning, and the chaos didn't stop there. All around, the solar system was filled with debris, rocks, asteroids, and planetesimals left over from planet formation. Every day, thousands of them slammed into Earth. Some were no bigger than cars, others were the size of mountains. Each impact released enormous energy, enough to melt rock, blast craters hundreds of kilometers wide, and even temporarily vaporize parts of the planet's surface. This period, known as the Late Heavy Bombardment, lasted for hundreds of millions of years. It was the most dangerous time in our planet's history. The entire surface was repeatedly melted and reshaped. If you could stand on the surface, not that you would survive, the sky would be filled with falling fire. Massive impacts would light up the horizon like miniature suns. The air would be thick with steam and volcanic gases. But this violent era was also shaping the planet we know today. With every impact, Earth grew larger, gaining more mass and a stronger gravitational pull. Iron and heavy metals sank toward the center, forming a dense, molten core. This core would one day generate Earth's magnetic field, a shield that protects us from deadly solar radiation. Volcanoes were everywhere, constantly erupting and spewing gases into the air, Carbon dioxide, methane, water vapor, ammonia, this was Earth's first atmosphere. There was no oxygen yet, and certainly no life. But these gases would play a crucial role in the planet's future. And while this sounds like pure destruction, it was also a time of creation. With every fiery impact, new chemical elements were mixed into the crust. Water-rich asteroids may have delivered the first drops of the oceans yet to come. This was a world being forged in a cosmic furnace, a planet in the making. But the most dramatic event of all was still ahead. Because one day, something much bigger than an asteroid was on a collision course with Earth. Chapter 3. The Great Impact, Birth of the Moon. And then, it happened. The single most violent event in our planet's history. Far away, another world was traveling through space. Scientists call it Theia, a planet roughly the size of Mars. For millions of years, it shared an orbit with the early Earth until gravity pulled them together on a collision course. The moment Theia struck, everything changed. Imagine a planet hitting another planet at more than 15,000 kilometers per hour. The energy released was so great that the entire surface of Earth melted again. Mountains turned into rivers of lava. The atmosphere boiled away in seconds. Chunks of rock the size of continents were blasted into space, forming a glowing halo around the Earth, a ring of molten debris. If you could have looked up, you would have seen a spectacular, terrifying sight. A glowing ring encircling the entire planet, shining brighter than 1,000 full moons. At first, Earth must have seemed destroyed, but slowly the debris began to gather. Gravity pulled it together into one large body. Over weeks, months, maybe years, this glowing mass cooled and solidified. And then, something new appeared in the night sky. Our moon was born. This was no small gift. The moon would go on to shape the destiny of Earth. Its gravity stabilized the tilt of our planet, giving us regular seasons. It slowed Earth's rotation, preventing days from being just a few hours long. And its tidal pull would one day help stir the oceans, an important step in the rise of life. But in the short term, Earth was a nightmare world. Its surface was still molten, glowing like a red-hot ember. The sky was choked with rock vapor, and the newborn moon glowed much closer than it does today. So close it looked enormous, filling half the horizon. And yet this catastrophe was a turning point. The Earth that emerged from this impact was different, larger, with a molten iron core fully formed, spinning fast and generating a protective magnetic field. This was the Earth's second birth. And now, for the first time, it was ready to begin cooling down for good. Chapter 4. Earth cools and breathes. After the Great Impact, Earth was a world of fire once again. But this time, something was different. It was the last time our entire planet would be completely molten. From now on, it would begin to settle into the world we know. Slowly, over millions of years, the surface began to cool. The magma ocean hardened into the first rocky crust, thin and unstable at first, cracking and shifting like a fragile shell. Underneath, the mantle still churned with heat, and volcanoes erupted everywhere, constantly resurfacing the land. But something remarkable was happening in the sky. The vaporized rock and gas from the Theia impact was condensing, raining back down to Earth. Steam from endless volcanic eruptions filled the atmosphere, making it thick with clouds. And then, it rained. For thousands of years, the rain never stopped. The surface hissed and boiled as the first drops fell onto the still hot crust. But over time, the rain cooled the planet further, filling its great basins with water. The first oceans were born, vast, dark, and alien. Imagine standing there, if you could. The sky would be a coppery red, filled with storm clouds. The seas would be hot, acidic, and violent, waves crashing over barren volcanic islands. And yet, This was the beginning of a stable, water-covered planet. The atmosphere was still toxic by modern standards, full of carbon dioxide, methane, and ammonia. But this was critical. Without a strong greenhouse effect, the young sun, which was fainter than today, might not have kept Earth warm enough for liquid water to stay. In a way, these gases acted like a planetary blanket, protecting the first oceans from freezing. Deep below, the tectonic plates were starting to move. The very first continents began to rise, forming tiny islands in the endless sea. Over millions of years, these would grow and merge into the first supercontinents. Earth was breathing for the first time, its water cycle and atmosphere forming a dynamic system. The worst of the chaos was over. Now, with a stable surface, oceans, and an atmosphere, the stage was set for the next great leap, the emergence of life. Chapter 5. Gifts from the sky. Even as Earth was cooling and the first oceans formed, the skies were anything but quiet. The solar system was still full of debris, countless asteroids and comets left over from planet formation, and many of them were still heading straight for Earth. But this time, these impacts were not just destructive. They were delivering gifts. Some of these cosmic visitors carried water locked inside their ices. Every time they struck, more water was added to Earth's growing oceans. Today, scientists believe a significant portion of our planet's water may have arrived this way, delivered from the outer solar system. And water wasn't the only thing these messengers brought. Inside certain meteorites, scientists have found amino acids, the basic building blocks of proteins and perhaps of life itself. Imagine that, rocks falling from the sky, carrying the ingredients of biology. There is even a theory called panspermia, which suggests that life's very first seeds, simple microbes, might have traveled through space on meteorites. We cannot yet prove this, but it reminds us that life may be more widespread in the universe than we once thought. Each impact stirred the oceans, added new chemistry, and set the stage for something extraordinary. Our planet was no longer just a ball of rock and water. It was becoming a cosmic laboratory full of potential. And somewhere, deep in those oceans, something truly remarkable was about to happen. Simple chemistry was about to turn into biology. Chapter 6. The first chemistry of life. With oceans covering much of the planet and chemistry pouring in from space, Earth had become the perfect setting for something new to emerge. But how do you turn lifeless molecules into something that can grow, replicate, and evolve? Deep beneath the waves, near volcanic hydrothermal vents, hot water rich in minerals gushed into the early oceans. These vents created pockets of heat and energy, natural chemical reactors. Here, simple molecules like carbon dioxide, methane, and ammonia mixed with water, forming more complex compounds. Scientists believe that in this environment, the first amino acids may have formed, the tiny building blocks that make up proteins. Elsewhere, perhaps in shallow pools heated by volcanic activity, energy from lightning or ultraviolet sunlight may have sparked new chemical reactions. In the 1950s, scientists Stanley Miller and Harold Urey recreated this idea in the lab. By simulating the conditions of the early Earth, they were able to produce amino acids in just a few days. This was proof that life's raw materials could form naturally. But amino acids alone are not enough. They must come together into proteins, and those proteins must somehow cooperate with other molecules like RNA, capable of storing and copying information. This step remains one of the greatest mysteries in science. Perhaps life began in many places at once, with countless failed attempts, until one lucky combination created something that could copy itself. That first self-replicating system might have been fragile and simple, but it was the spark that would one day lead to every plant, animal, and human that ever lived. We may never know exactly where it happened, in a deep sea vent, in a shallow warm pool, or with the help of molecules delivered from space. But we do know this: once it began, nothing would ever be the same again. Somewhere on this young alien world, lifeless chemistry had just crossed the line into life. And with that single microscopic step, evolution's long journey had begun. Chapter 7. The Calm Before Life. For the first time in its history, Earth was stable. The great impacts had ceased. The magma oceans had cooled, and the surface was covered with water. The storms still raged, the skies were red, but beneath that chaotic surface, something quiet and steady had begun. Continents slowly grew, tectonic plates shifted, volcanoes rose and fell. Yet the planet was no longer in constant danger of being destroyed. It was no longer just surviving, it was preparing. The atmosphere had settled into a greenhouse mix that kept the oceans liquid. The magnetic field was strong enough to shield the surface from the sun's deadly radiation. Earth had everything it needed for life to take root. And in the oceans, invisible to any eye, tiny molecules were combining, copying, and competing. This was the very first form of evolution, chemical evolution, slowly exploring possibilities until one worked. Earth had gone from chaos to calm, from fire to water, from dust to the edge of life. Everything was in place. All that was missing was that first, improbable leap, the moment when chemistry became biology. Earth was forged in cosmic fire, tempered by catastrophe, and transformed into a cradle for life. But what happened next would change the planet forever: the birth of the first living cell. Join me in the next episode of Echoes of Deep Time as we explore the mysterious dawn of life itself. Subscribe now so you don't miss the moment when Earth's story truly begins.